Let's solve this problem, which is, I must admit, quite long, but it will be perfect to reinforce your learning, okay? Because it covers kind of everything. So this problem 6 says, calculate this integral, and this is a circulation, because you see this circle here, yeah? And also you see I wrote it in the format something times dx plus something times dy, which was the alternative way of writing f.dr, okay? And what is the path L, the curve? So this is the loop OBBAAO between 3 points in a straight line. Okay, so let us write everything. So we need to calculate this integral, which is j, which is the circulation of 2xy dx plus x squared dy. Okay, so this, remember, is just the same as asking for f dot dr, simply that we are using f equals this function 2xy and x squared as the x and y components respectively, and dr is simply dx and dy. Okay, and what about the path? So the path is very important. So it's a path joining the origin to point B, then point B to point A, and then point A with the origin. Okay, so maybe here actually I could write that O is the origin instead of C. So let's do that. Let's plot that. If I write my two axes, so this is x and this is y. So first let's locate the 3 points. So we have point O, which is the origin, which is this point here, 0, 0. Then we have point A, which is point 0, 1. And then we have point B, which is 1, 0. So here. Okay, so our path is from 0 to B, from B to A, and from A to 0. So we are doing this. Then from B to A, and then from A to 0. So this is our path. Okay, which means that we are going to have to do 3 separate integrals, and we are going to give them names. So our integral j is going to be the sum of 3 integrals: the integral from 0 to b, plus the integral from b to a, plus the integral from a back to o. Okay, and since this is a closed path, this will be the circulation of this field. Excellent. So let's start. So let's start with the first integral, JOB. So let's try to be quick about this, okay? So I'm going to do the steps, but I'm going to be very concise. So first step is to parameterize the curve. So this is a straight line from the origin to point B, okay? So you can either say that R of U is equal to the origin, point O, plus U times B minus O. Yeah, you can do this. So this will be equal to 0, 0 plus U 1, 0 minus 0, 0. Remember how did I know this? This was the general way to write the parametric equation of a straight line, which you end up being, you can write this as U times 1, 0. Okay, so that's your parametric curve. In my opinion, you should have enough intuition after doing lots of problems to be able to write this directly. So when u equals 0, you start at 0, and when u equals 1, you end up at 1, 0, going through a straight path. So I think this is easy. You don't need to apply formulas. You should be able to maybe write this directly, okay? So the limits of u are between 0 and 1. Okay, so that's step 1. Step 2 is to find dr. And to find dr, we are going to do dr, the derivative of dr with du times du. And this is easy because the derivative of u0, yeah, so realize that this is just u and 0. So the derivative of that is 1 and 0 times du. Perfect. 3. Evaluate integrand at curve. So please remember that this dr is now du and 0, which you can see that this is dx and dy. Okay? So now evaluate the integrand at the curve. So the integrand, either we do f dot dr, so we do this vector dot this vector, or we substitute the integrand here where the dot product has already been done for us. Okay? So I don't know what you prefer, but I think it's clearer if I just do f dot dr like this. Let me write it. Qxy x squared dot dr, which is u0. Sorry, not u0, is 1 0 times du. Yeah. So this is dr. So now we do this dot product, but we also need to evaluate x and y at the curve, right? So remember, we need to substitute x as a function of u, and what's x as a function of u? Is u, and y as a function of u, which is 0. So we need to substitute that. So this becomes 0 and u squared dot 1 0 du. And we are fortunate because this dot product will be 0 times 1 plus u squared times 0, so it will be 0 du. So the integrand is 0, which means that the integral is also 0. Okay? Now this makes sense because when you are in the x-axis, when you are in this path, so y equals 0, which means that your field is 0 and x squared. So your field would look something like this. And this is extra, right? You don't have to do this when you are solving. I'm just trying to give you some intuition of what happened. So the field is always pointing in the y direction, and it's increasing as we increase x. But of course, this field is always at 90 degrees with our path, and therefore f dot dr is 0. Okay, so that's why the integrand was 0, because f dot dr was 0. Let me give you a shortcut for this first result that we did following the steps. As I said when I taught the steps to you, these steps are for beginners. If it's the first time you're calculating this type of integrals, it's great to follow the steps. But once you get used to doing these integrals, sometimes you don't have to explicitly follow the steps. And for example, we can start with the integrand itself. So let me duplicate the integral here and place it here. So we are doing from O to B. So we are integrating from x equals 0 and y equals 0 to x equals 1 and y equals 0. Okay, so we are integrating from point O to point B. So now you can kind of see that dx, we will leave it as dx. So x will be our parameter, so we leave it as x. Y is equal to 0 throughout the entire curve, so y we can leave it as 0. Dx, we will leave it as dx because we are changing x. Then x squared, we can leave it as x squared, but importantly, dy is going to be 0 because we are not moving along y, we are only moving along x, okay? So the way in which you saw this is that when you calculate dr, you found that the y component of dr was 0, which means that dy is 0 because you are not moving along y when you go from O to B. Okay? So therefore you can do these substitutions without having to do all of the steps, and then you come here, you arrive at that this is equal to 0 dx plus 0, yeah? And x is changing from 0 to 1, so this is the integral of 0 dx from 0 to 1, which is 0. Okay, so you can kind of do it directly if you know how to intuitively find what dx and dy are from looking at the path. Okay, excellent. So now we calculate the next leg of the journey from B to A. Okay, so that will be JBA. This was OB. So JBA. So as before, I will follow the steps. And in this case, it's not so easy to do it directly, substituting the x and the y, because it's not clear what's the x and what's the y unless you do follow the steps. Okay, so this will be purely with the steps. So first step, we parameterize the curve. So we are getting r of u. We are going to say that r of u is equal to the first point, which is b, plus u times the last point minus the first point, a minus b. Okay, so this is equal to 1, 0 plus u times a is equal to 0, 1 minus b, which is 1, 0. So this is equal to 1 minus u and u, with u going between 0 and 1. It's always a good idea to check that the parameterization makes sense. So if you substitute u equals 0, you get 1, 0. So you start here. And if you substitute u equals 1, so your slider, you move it to the right. So then you get 0, 1. So when you move the slider to the right, you move to 0, 1. Yeah. So indeed, it seems that you are really moving along this straight line. So things look good. So 2, you find the r. And the way you do it is that dr is simply the derivative of r with respect to u times du. Okay, so we need to do the derivative of this with respect to u. So we get minus 1, 1 times du. Okay, and this will be equal to dx and dy. So this is our dr. 3, you evaluate the integrand. Okay, and to evaluate the integrand, we write the integrand as f dot dr. So let me write it here, f dot dr. So f is equal to 2xy and x squared. And dr is equal to minus 1, 1 du. But of course, we need to substitute x and y in terms of u. Okay, so we need to substitute x and y in terms of u. So remember that this is x and this is y. So we need to, whenever there is an x, I need to write 2 times 1 minus u, and then there is a y here, so I need to write u. And then on the bottom we have x squared, so I need to write 1 minus u squared. And then this dot minus 1, 1 du. Okay. So if we carry out this dot product, we get 2 times 1 minus u times minus 1 times du plus 1 minus u squared times 1 times du. And we elaborate, this will be a polynomial in u. So we end up with 3u squared minus 4u plus 1 times du. And now this is our integrand, which is ready for integration, right? Because this is a function of u only times du. So this is ready to integrate. So for calculate, integrate. So the integral from b to a is equal to 3u squared minus 4u plus 1 du. And what is our parameter u? What is the variation of u? U is going from 0 to 1, so this goes from 0 to 1. So we have to calculate this integral. This is very easy. The integral of 3u squared is u cubed minus 2u squared plus u, evaluated from 0 to 1, which is equal to 1 minus 2 plus 1, so 0. So the next leg of the journey was also 0, okay, interestingly. Fine, and now we are left with the third and last leg of our journey, moving from a to 0, okay? So let's do that, j from a to 0. So first, parameterize the curve. So we are going to do as usual, and it's going to be R of u is going to be the starting point, which is A, plus u times the ending point, which is O, minus the starting point, which is A. Okay, so we are going to get A is 0, 1, plus u times 0, 0, which is the origin, minus 0, 1, which is A. So we end up with 0 and 1 minus u. Okay, for when u goes between 0 and 1. Like before, I suggest you check to see if this makes sense. So when the slider is on the left, u equals 0, so you get 0, 1. So you start at 0, 1, you start here. And when you move the slider to the right, u equals 1. So when u equals 1, you get 0, 0. So you are moving downwards to the origin. Okay, so this is working. Moving the slider from left to right is moving us from A to 0. Perfect. So next step is to find the R. And in order to find the R, we just have to do dr over du times du. So this is very easy because we have dr here. So the derivative is simply 0 minus 1 times du. Okay. 3, evaluate the integrand. So now you have to do f dot dr, and f is equal to 2xy x squared, 2xy x squared, dot dr, which is 0 minus 1 du. But of course we need to substitute x and y, yeah? So we need to substitute x equals with what and y equals what. So be careful, you have to substitute the curve. And which curve? The one that we are using now. So this is our curve, R of u, okay? So this is x and this is y. So this is going to be equal to 0, because 2xy is 2 times 0 times 1 minus u, and x squared will be 0 squared, so this will be 0 dot 0 minus 1 du, which is equal to 0 du. So this integrand is also 0. This integral is also 0. So calculate the integral. J from a to 0 is going to be the integral of 0 du between 0 and 1, which is 0. Okay? So actually the 3 legs of the path gave us an integral that was equal to 0. So the total circulation is just the sum of the 3 is going to be 0. Okay, and that solves our problem.